Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman. Hey, Ben, how are you?
Hey Simon, hey fellow Econauts, how's it going? Today we have a heavy topic.
What is artificial gravity?
I don't want to go too much into the science here, but in a nutshell, obviously our planet has a certain mass and therefore we are attracted to the surface. With a spacecraft, we cannot do that. We don't have that big of a mass available, so we have to find other ways to artificially put us on the floor, so to say. So that is artificial gravity is to artificially make us heavy in our respective environment. So if we're on a spacecraft and we define one side is down, that is the floor, we want to be able to walk on that floor.
How can we achieve artificial gravity?
A part of making the spacecraft super heavy on the side where we want the floor, which is obviously a bit out of the question. Currently, there's only two other ways we can achieve that. One is by linear accelerating the spacecraft in one direction. So we have to become faster and faster and faster and faster. Pretty much the same way that flat earthers believe we are staying on our flat Earth because they think the plate is accelerating in one direction permanently. Um, so not really an option as well. The second and more viable way to do that is by having a rotating structure and defining the floor on that outer circumference from the inside. And because of the centrifugal forces, you are sort of pushed towards the outside, and then you can walk along that floor.
Which is something that you can easily see when you are looking into a washing machine. You can see your clothes going.
Exactly. Ooh.
All right. So, why do we bother getting us into an artificial gravity?
I think the more obvious reason is for mental well-being. You don't want to float around all the time. You want to, be able to walk a little bit and feel normal. Anything that is not normal has a potential to, pose mental stress. The second point, which might not be that obvious, but is very important, and I guess a lot of people have heard about that. Astronauts who spend a prolonged time on a space station, for example, they often have atrophy in their bones. So the bone density reduces a little bit, the muscle density reduces a little bit. They straighten a little bit, but when they have to go back on Earth, they are weakened. So they constantly have to do training to counter these problems.
What are the challenges when you try to build an artificial gravity?
We have pretty much excluded for this discussion linear acceleration and building a very heavy spacecraft. So I will not go onto the challenges for those two solutions. So we focus on the centrifugal solution. When you have centrifugal parts, first of all, you have to design the whole spacecraft in a way that it allows for such a motion, especially if you have that are connecting other parts with each other, um, maybe even of different circumference and diameter and so on. Then you need to have different speeds. So now you get connections that are moving with different speeds. So therefore, you have to seal better. So that makes it a bit more complex. The other problem is also if you have to change from areas. For example, let's say you have a big ring and you walk on this, but now you have to move to an inner ring. Obviously, the gravity will be different because you're now in a, still having the same rotational speed, but not the same diameter anymore. So you will experience different gravities depending where you are on the diameter of your spacecraft. So this poses other challenges, not only for people that are transiting between those areas, but also if you're transporting other things like oxygen and other gases and fluids, that will make a huge difference. Another problem might be more mundane, could result in a dizziness for people, because there's something called the Coriolis effect, which will still affect your ears. So you might actually feel a little bit of that rotation, depending also where you are on the diameter. And I think this could actually be. It might sound very little, but imagine you have to be dizzy for like 7 months to travel somewhere. Let's say Mars, for example.
All right, fellow Econauts, and now we would like to know from you. What do you think? How long could you survive in artificial gravity? And if you like this episode, don't forget to leave a like and subscribe if you haven't already.
And also let this artificial gravity pull your finger towards the notification bell so you don't miss out on any episode anymore. I also encourage you to go through our catalog with a lot of episodes that should be interesting for you too.
And I hope I will see you next time. Have a good one. Bye bye.
See ya.